Hi everyone, this the assignment matrix for the exercise 14G for the question 11C and D, which is have some students request for the solutions. Okay, so we start 11C. Okay, from 11C, this question is a comment on the following arguments for a 2 by 2 matrix A is 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 known here in it is known that a square equal to a, and then this the question give to us. So this question actually is from the question B also. If you do question 11B already, okay. Question 11B, they ask you, they give you a, sorry, a equal to this one, 1 over 2, 1 over 2 for each element or each entry or equal, or every element is equal. Okay, so this one we call equality matrix. Because every element equal, so equality matrix. Then from question 11B, they give you a equalities and they want to find a square. They want you find a square. If you already finish this 11B, you will find out that a equal to a square is true, because when you do it's gonna be matrix A times matrix A, right? So and then you use the multiplication, then both of them will equal. From that's why they come to 11C, say it's known that this one equal. Okay, so this have to be proved from 11B, because it's not necessary every time say a square equal to a, but in this case because each element is 1 over 2, 1 over 2, right? When you try this one, they're really equal. But if you try another number, right, make it equal. For example, you can try another sample. For example, say give a, sorry, equal to 2, 2 like this, right? And you can work, say a square equal to a or not. It's not, doesn't equal. It's not, okay? So in this question, they find out this one is in each case different, you have to try. But in this question, they only give this one. Then come back to the question, they say a square minus a equal to, or mean the zero matrix. Zero matrix means every element is zero, correct? Or every entry is zero. So then for this question, for now you can say it's false. This one false because from this line, right? From this step, it doesn't imply to this one. This one doesn't imply to this. Okay, even though if you replace a here, right? For example, from this line, from this step, if you test, right? You test like, for example, you test matrix A. Matrix A equal to 1 over 2 and 1 over 2. This one 1 over 2, 1 over 2. Okay, and then the whole thing time matrix A is what? 1 over 2, 1 over 2 again, right? And this one, then you minus identity. Identity means what? 1, 0, 0, 1, right? Because this one, matrix A is what? 2 by 2. This one 2 by 2. So identity should be 2 by 2 as well. Okay, so then from this one, you can try it. I'll let you try. Okay, you simplify, see this side equal to zero matrix or not. So this one, see from the left, when you simplify, must be equal to this one, whether or not, whether equal or not. Okay, even though from this step, this minus, okay, from this question, from this line. I think I tried already that they're equal to zero matrix, but you see from this step, right, down to this line, to this one, right? It's very obvious. Matrix A equal to zero matrix, which is impossible, correct? And because A equal to the each element is 1 or 2, 1, 2, 1, 2 here, but zero matrix is 0, 0, 0, 0. And at the same time, at the same meaning, same concept is what? Same how to analyze. A equal to this matrix, but I is what? Identity matrix. I is should be what? Like this one, 1, 0, 0, 1. But A is what? 1, 1, 1 or 2, 1, 2. So it doesn't equal. So cannot apply. The meaning is, you remember the first period, I give you the comparisons table about the ordinary algebra and matrix algebra. Okay. Most of matrix couldn't lie in this. It's not implied for that. It's not algebra because matrix have to concern because matrix they have inside each element inside there. So it's not like algebra. Algebra is only one number, single number, and then you can solve it that way. But now A is a matrix. Okay, so we shouldn't lie in this way. So this question for 11C is 4. Okay, it's 4. The reason just say from A times A minus I identity here equal to 0. From this one is does not imply to the this step because this one not equal, right? This one shouldn't, they are not equal anyway. You can see really clear. Okay, and A and this one not equal to 0 either. Okay, doesn't equal to 0 neither. Okay, so then that's a reason you just explain from this line. Doesn't imply for this step and this step. Because A equal to this, 0 matrix equal to this, and A equal to this, how come gonna equal to I which is equal to this one? Is each element not the same? Okay, so that's a reason to answer for and explain by that way from this line. Because this is not algebra. If algebra maybe can do that way. Okay, so that's 11C. Now okay, next one, question 11D. Question say find all 2 by 2 matrices A for which A square equal to A. Let A equal to A, B, C, D. Okay, so this one, what we can do is have to find this A, get this one, because this one they give us hint, use this one, use this element. Okay, so start from this one. Okay, start from A square equal to A. So because of, okay, now solution. Because we have this one, A square equal to A, right? So we replace, become matrix A times matrix A. So we have A, B, C, D times A, B, C, D equal to matrix A, B, C, D. Okay, then we do the cross multiplication. So this one times this first row times first column. So become A square plus BC. C. Okay, and then this first row, second column become AB. This one become AB plus BD. AB plus BD. Okay, now write the matrix pattern. So second row, first column. So CA or AC become AC plus DC. And this second row with the second column become BC plus D squared equal to this one. A, B, C, D. So this we get the matrix identity matrix. So the same location here, first row, first column equal to the first row, first column. So A square plus B square equal to A here. A square plus B square equal to A. And then this one, AB plus BD equal to B. So we have AB plus BD equal to B. And this one, AC plus DC equal to C. So we have AC plus DC equal to C. And last one here, BC plus D squared equal to D. So BC plus D squared equal to D. Then we let this one become equation 1, this one equation 2, and this one equation 3, and this equation 4. Okay, so then we simplify for each one, try to get A, B, C, D. That means we want to get the matrix A, what is the represent for, okay? Then let me maybe do on this side. Okay, so from equation 1, we simplify. From equation 1, we have this one, and write it down, become move A square to this side, so become A minus A square. A minus A square equal to BC. A minus A square to BC, okay. So in this case, I can get anything. If I want, okay, we want to find out C, right? So I have A minus A square over B equal to C. Okay, I leave in that way first. And from the equation 2, I move B to this left-hand side. Move B to left-hand side, become AB plus BD minus B equal to 0. And then you see we have common factor B, right? Get B out. So have B, we left A plus D minus 1 equal to 0 here. So from this one, we got B equal to 0. And another equation, A plus D minus 1 equal to 0. So I move minus 1 right away. So become A plus D. A plus D here equal to 1. Okay. A plus D equal to 1. We like it. A plus D equal to 1. Okay. After that, see equation 3, what we can do. Equation 3 also move C to this side because I see the common factor C, right? So become AC plus DC minus C. So I have AC plus DC minus C equal to 0. Then I get common factor C, right? So I have A plus D minus 1 equal to 0. Then I have C equal to 0. And then this is a bracket, correct? Okay. So I have AD equal to 1 and move 1 to the other side right away. Okay. Then equation 4, what we can do. We observe here now we have, how many we have here? We have this B already, value B, and have A plus D equal to 1. And also we have C equal to 0 and A plus D equal to 1. And we have C here. Okay. From this one. Okay, now we do equation C, equation 4, what can do? BC, this one BC here. BC equal to this one. Okay, so I replace BC in here. So equation 4, just say replace BC. I should say maybe I like this one become 5, right? From equation 5. Say from 5, replace BC into 4 into equation 4. So we replace in there now, BC replace in here. So we have a minus a square plus d square, but then they move d to this side right away. So become minus d here, equal to 0. Okay, now I rearrange. I want to, they look like have AD, so should have some common factor, right? So this is a d square. So I rewrite down become d square minus a square. And then minus d minus a equal to 0. So this one, I factor it, become d minus a plus, time d plus a and minus d minus a. So I got a common factor. So common factor is d minus a, take it out. We left d plus a minus 1 equal to 0. Okay, so I like in this side. So from this one, what we have two brackets, right? So d minus a equal to 0 and d plus a minus 1 equal to 0. So that means I have d equal to a, right? And this side become d plus a equal to 1. Equal to 1. So I got this one, this another one I have. Then again, observe this, we got d equal to a and d plus a equal to 1, same as this one, right? So either this equation a plus d equal to 1 or either one, 3 of these, we try to get d correct. So from this one, just say, we form this one. Okay, I'm trying to get d. So d equal to 1 minus a. D equal to 1 minus a. Then I'm kind of get some matrix, matrix A now. Okay, so I will leave A, B there because I know, okay, can I work more from here? From this line, okay? Come back. This another color here. From this one, because if I have, say I have C, either C or B equal to 0, right? So if I replace C equal to 0 here, so B times 0 becomes 0. So from here, just say in this one, if C equal to 0, from here, from equation 3 here. So B times C, this is 0, so becomes 0. So I got this one become what? Okay, from this one, I have a minus a square equal to 0 also, correct? So then I have common factor a, take it out, become 1 minus a equals to 0. So at the same time, I got it a equal to 0 or 1. So I have this one from here, okay? So I got a, now see this. I have a can be 0 or 1 and b become 0. But in this case, if you got c from here, see this one, maybe use different color. From this one, right? Because c here, right? So in this case, right, b shouldn't be 0. If 0 become undefined, right? So I kind of get the answer now, I think. You can analyze it. So from this one, right? I write the matrix A down. So matrix A, I got here A equal to, I leave A as A here because I will explain later. And then C, I have this one, become A minus A square over B. Okay. And then D is here. So D is a 1 minus A. Okay. So then you, right now you can analyze it by if, so question straight on when value of A, the matrix A have to be in this pattern because they refer this one, right, from the period. Question is related to the matrix, zero matrix, which is 0, 0, 0, right? And the identity identity matrix is a 1, 0, 0, 1. So you can see each cases. If you want to do the first one, 0, 0 is a 0 matrix. So that means this A become, this A is a 0, correct? This one, consider it. This A gonna be 0, correct? And then this B in this location, that means the first row, second column, first row, the second column here. This B can be 0, which is we have it here. But for the C here, value of C here, B shouldn't be 0. If 0, this one become undefined. Okay, but in this location, see this one. From this one, right now we analyze for this term. Because what A minus A square over B is equal to C, correct? Okay, so but B couldn't be 0. Okay, but C can be, but this term, right now we try to get this one correct, get the 0 matrix. So this term has to be 0. Okay, but this one be equal to this one. But B, of course, B not B is not 0 because condition here, right? But C can be 0, correct here. So then this one time becomes 0. So if C equal to 0, then A square, I mean, sorry, should be then A, then A minus A square gonna be equal to 0 also. If C equal to 0 in this case. And then we can see this is 0 because of what? A can be either 0 or 1. So in this case, A can be 0 or 1. If 1, 1, 1 minus 1. If 0, 0 become minus 0, 0. So this case is okay. You consider in this way. Okay. But then in this term, have to be 0, correct? So 1 minus A. In this case, A can be either 0 or 1, correct? Right? But in this case, in this location, that means the first row, second row, second column here, A must be 1 only. This is 1 here. A here can be 0 and 1. So A must be 1. So this location gonna be 0. So you analyze like this. So all this question have to analyze in this way because, and then you can analyze this identity matrix, do the same way. Okay, so you replace A should be 1 because A can be 0 or 1. So this one okay. And B, this one can be 0, okay. Okay. So you do the same way how to analyze. So final answer for this one. Final answer for this question is Is this one okay? Is this one final answer? Matrix A equal to this one, which is gonna explain to what? To this one, C equal to this, which is B not equal to 0, and form what all the one I underline here, and this one in the box here. Okay, that's the way how to do for this question. Okay, all the underline here will support each element for the matrix A in case of zero matrix and identity matrix. Okay, I think that's all for this question. It's a good one. I have to analyze a lot. Okay, I think that's it. Thank you. Bye bye.